Okay, starts out the same again, always. Take the derivative of both sides of the equation. So, I take the derivative of both sides. The left side is going to become dy over dx. To maintain equality, I must take the derivative of the other side. Questions? So raise your hand when you know what rule to use. This is how the next 2 weeks goes. This is it. Just practicing. You just have to keep encountering different situations and figure out how to use the rules you have for all kinds of different situations. So what rule does this one, what rule matches up here? Hands, please. What rule matches? So Alec, E-roll. Now, I'll be honest with you. I try to always be honest, except when I'm telling dumb stories about stamps that say you're an idiot. Okay. There is no such thing as the E-rule. Like, I don't think you find this online or in a textbook or anything. But having taught AP Calculus for 12 years, I found that if I give you a rule that we call the E-rule, you're really happy. Like, it just makes a lot of calculus problems go faster. Technically, you just use the exponential rule because here the base is E 2.7. Here the base can be anything, 5, whatever. But most of the problems they give, they use E as the base. So if we just memorize this rule, it just goes a little bit quicker. So how many knew it was the E rule? 2 points. Then we just apply the rule. Oh, here's one I haven't told you. You already knew this, I just don't think I've written it on the board. dy dx means change in y over change in x, rate of change, tangent slope. This symbol means the same thing. Y prime. So the E rule says this derivative is e raised to the same thing multiplied by derivative of that same thing. Oh, Bryn's question about how to memorize it, that's how I memorized it when I had the class in college, is I would memorize the E rule as this. I wrote down exponential, I should have grabbed the E rule. Let's go look at that. I memorized the E rule as the derivative of e to the something. So g of x just means anything, is e to that same something times the derivative of the something. Because all of the rules up here at the top follow that pattern. Because all of these rules are not the textbook rules, they're my enhanced rules, where I've already combined the chain rule with all the simple rules to make life easier, honestly. Because that's how you end up using it. So like ln, the ln is natural log of something is 1 over the something times the derivative of the something. Sine is derivative of the cosine, sorry, derivative of sine of something is cosine of something times the derivative of the something. So the second half of the rule is the same for all of them. So all you have to memorize the first part. So it actually goes pretty fast. So back here. Questions? What rule is next? Hands up. Show me your hands. What rule is next? As I said before, we just keep starting over. We use a rule, then we just start from the beginning. What rule is used next? Let's go, Chase. So remember, this part you don't even look at. Everybody look here. Remember, this you don't even look at because there's no ddx operator. So when we went from this line to this line using the E rule, okay, the E rule has taken care of this portion of the function. This is done. Don't do anything with that. You're looking for the ddx operator. So you see ddx of this. So what rule applies to ddx of this? Hands again. What rule applies? Ty?
The power rule.
So I come over to the power rule, and I say I've got ddx. So I've got to identify g and n. So Ty, what's the g?
4x.
The g is 4x. What's the n?
4.
4. Okay, 3 points for Ty. How many thought that? 3 points as well. Okay, that's a common mistake. So we don't want to. Does anybody know what the error is?
So is it like what we said on the board, like if there's no parentheses, then it's actually 4 is multiplying by the x to the 4? So then would we use the multiplying?
Yeah, the power rule doesn't work. We need me to talk through it some more. So for the power rule to work, you must have d over dx of whatever to the 4th power. So you've got d over dx. So what's being raised to the 4th power? Just the x. The power rule doesn't have a little space in here for a 4. Like the power rule would have to look like this, and we'll actually do this later. That's what the power rule would have to look like.
Yeah.
The 4 is making it so we can't use the power rule.
Yeah.
In a few days, I'll give you another rule that is handy. It's a combination of the multiplying constant and the power kind of put together, and that's a little different. But so can't do that. Anybody want me to talk more about why you can't use the power rule? So using the multiplying constant rule, you get this. Y prime equals we'll have 4 question. Another key thing to make sure you're always doing is make sure as you go from line to line, you don't lose track of, like, are we multiplying, are we adding, you know, keep the equality. So now what rule? Hands. What rule gets used now?
Here's our inverse equation, yeah?
Let's go, Charles.
Now it's the power.
Now it's the power. So what's the g of x, Charles?
X.
Perfect. And what's the n? 4. Perfect. Just plug it in. How many knew it? Points, 3 for Charles.
All over 2 over x minus 3.
The 4 is customarily written in front of the e. They're just two things being multiplied. So order doesn't matter, but it's a little more familiar to write the 4 in front. Don't forget the dx over dx.
So, I'll just keep going, and then we gotta go on to learn something good.
Question?
Here we go. If you multiply by the reciprocal of this,
Please.
So when in the power rule, when you do n minus 1, so since there's like in the first equation, there's like 4 x's, then do you subtract 1 from the exponent because the other one goes to the dx over dx?
Oh, 5 points. It's a really good observation. It's not really what's happening.
Okay.
What's happening is kind of complex,
Okay.
and that's why we didn't spend time in class really showing it. So no, that's a really good way to, I mean, that's interesting you thought of it that way, but no.
Okay.
No worries. There we go. Cool. This becomes 1. I've got, let's see, 1, 2, 3, 4 factors. So I can combine some factors to make writing the final answer a little bit simpler. They used to put the X in front. It's not required, but you know. Question? Please help. Right here. Were you okay here?
Yeah.
So what I have is 3 factors being multiplied. 1, 2, 3. Order doesn't matter with factor. I just looked at it. Yeah, you don't have to. It's kind of tradition. 3 points.
So do you just know you're done when you don't have any more dx over dx?
Ever hear that? The whole idea is, at the very beginning, we're applying the ddx operator. We use the rules to get the, I honestly think of it a little bit like the old-fashioned video game Pac-Man. Anybody know this game? Nod if you know this game. Yeah, okay. Very familiar, right? Famous game. The derivative operator eats its way through the problem. It starts by eating the whole thing. When it's taking care of the e, now it just has to eat this. You pull out the 4, it's taking care of that. Now it's got to eat this. Once it's done that, it's done. So when there's no more derivative operator, you're finished. Cool. Next one.